Question 1. For each statement below, indicate whether the answer is true or false. Azure AI Foundry exposes a REST API that can be used to work with projects and their resources. True. True. SDKs for different languages may not have identical functionality at the same time. Answer. Each AI project has a unique endpoint used by client code to connect. Answer. True. The AI project client in Python requires Azure Identity to be installed to use default Azure credential. Answer. True. Now I'm going to explain why each of these answers is true, step by step. Firstly, Azure AI Foundry really does provide a REST API, so applications can send HTTP requests to manage projects and whatever resources they contain, which confirms the first statement. Secondly, language-specific SDKs are built and updated separately, so a new feature might appear in the Python SDK before the C# SDK, meaning their functionality does not always match at the same time. Next, each AI project is given its own unique endpoint URL, and client code must target that exact address, just like a specific website address, so the third statement is true. Finally, default Azure credential depends on the Azure Identity package to discover and resolve credentials at runtime, so the AI project client must have Azure Identity installed, making the last statement true as well. Question 2. For each search technique in the item list, drag it to the definition in the option column that it precisely matches. Each item may be used once, more than once, or not at all. Matches documents by exact words terms in the query. Answer. Keyword search. Retrieves by understanding the meaning of the query. Answer. Semantic search. Finds similar items using embeddings numeric vectors. Answer. Vector search. Combines keyword and vector, optionally adds semantic ranking. Answer. Hybrid search. Now I'm going to explain why each search technique matches its definition so you can remember them easily. Firstly, keyword search lines up with matching documents by exact words or terms because it focuses on the literal tokens you type, just like looking up a specific product code in an online store. Secondly, semantic search fits with retrieving by understanding the meaning of the query, since it tries to capture user intent. For example, returning car results even when someone searches for automobile. Next, vector search corresponds to finding similar items using embeddings, because it represents text as numeric vectors and then measures how close those vectors are, similar to comparing coordinates on a map. Finally, hybrid search matches combining keyword and vector as it blends precise exact term matching with semantic similarity, giving results that are both accurate to the words used and relevant to the overall meaning, while other options like PageRank only retrieval or exact fielded SQL joins do not describe these techniques directly. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. To measure harmful outputs, teams build a diverse prompt set, run it to collect generated outputs, and apply predefined strict criteria to assign harm categories. The initial results form a baseline used to track improvements as mitigations are introduced. Now I'm going to explain how each part of this process fits together and why these options are correct. Firstly, a diverse prompt set is essential because it represents many real-world ways people might query the system, so you can see a wide range of possible harmful behaviors. Secondly, generated outputs are what the model actually produces, so they are the evidence you examine for harm. Next, predefined, strict criteria keep the evaluation fair and repeatable, similar to having a fixed marking scheme for grading exams. These criteria let reviewers consistently label content into harm categories, such as violence or harassment, making patterns easier to spot. After that, the first round of measurements becomes a baseline, giving a starting score you can compare against later. Finally, as you introduce safeguards like better filters or prompt changes, you look for improvements over that baseline, just like tracking test scores over the school term to see whether your new study plan is working. Question 4. Fill in the blanks by selecting the correct options from the drop-down menus. An input is provided to a language model, which produces an output. Evaluation may analyze the input and output, and optionally compare the output to a predefined expected answer to judge performance. I am now going to explain how this whole sentence describes a simple evaluation setup, step by step. Firstly, we start with an input because every language model needs some text or data to respond to, for example, a user question or a prompt from an app. Secondly, that input is sent to a language model, which is the system that processes the text and decides what to generate next. Next, the language model produces an output, such as an answer, a summary, or some generated content, and this output is what we want to evaluate. After that, evaluation looks at the input and output together, since quality often depends on how well the response matches the original request. Finally, in many tests, we also compare the model output to a predefined expected answer, like an official solution, so we can judge performance in a consistent and repeatable way across many examples. Question 5. For each automated evaluator or metric group, drag it to its universally true function. Each item may be used once, more than once, or not at all. Uses AI models to score qualities like coherence and relevance. Answer: AI quality model-based scoring. Computes overlap metrics that require ground truth. Answer: AI quality NLP overlap metrics. Flags content safety risks across categories like violence, hate, sexual, and self-harm. Answer: risk and safety evaluators. Now I'm going to explain why each evaluator group fits its function so clearly. Firstly, AI quality model-based scoring uses another AI system to judge qualities such as coherence and relevance directly on the generated text, so it makes sense for the statement about using AI models for scoring. Secondly, AI quality NLP overlap metrics covers things like F1 or BLUE, which compare model outputs against ground truth references, so it correctly matches the definition about overlap metrics that need a known answer. Next, risk and safety evaluators are explicitly designed to detect issues like violence, hate, sexual content, and self-harm, so they naturally align with the statement about flagging content safety risks across those categories. Finally, tools such as a latency profiler or a GPU utilization monitor focus on performance and infrastructure rather than content evaluation, so they are not used as answers for these descriptions. Question 6. For each statement below, indicate whether the answer is true or false. Pricing for Azure AI services is fixed monthly regardless of usage. Answer: standalone Azure AI services often include a free tier SKU for evaluation. True. Azure AI Foundry resource type includes Azure OpenAI, content safety, and content understanding. Answer: true. All Azure AI services are universally available in every Azure region. Answer: false. Now I'm going to explain why each of these answers is correct, so they are easy to remember. Firstly, pricing is not fixed monthly because most Azure AI services charge based on actual usage, so costs change with how much you call the service. Secondly, many standalone services do provide a free tier SKU, so teams can test and experiment before paying for higher volumes. Next, Azure AI Foundry is designed to bring together multiple capabilities, including OpenAI, content safety, and content understanding under one consolidated resource type. However, service availability is not the same in every Azure region, so developers must always check regional product and model availability rather than assuming everything is offered everywhere. Question 7. A developer needs to deploy a custom generative AI model that runs on managed virtual machines within Azure AI Foundry and is built based on compute usage. Which deployment option should they choose? Select one answer. A. Standard deployment. B. Serverless compute. C. Managed compute. D. Local deployment. Answer: C. Managed compute. Now I'm going to explain why managed compute is the correct choice and why the other options do not fit this scenario. Firstly, The question mentions managed virtual machines and billing based on compute usage, and that description matches managed compute, which runs models in managed virtual machine environments and charges for the underlying compute that is consumed. Secondly, standard deployment is mainly associated with token-based billing for models that are already hosted, so it does not align with the requirement to bill specifically on compute usage for a custom model. Additionally, serverless compute is also token-based and uses Microsoft-managed endpoints rather than the custom-managed virtual machines described in the question. Finally, local deployment is not available as a deployment option in Azure AI Foundry, so it cannot satisfy the requirement at all, which confirms that managed compute is the only option that fits every part of the scenario. Question 8. Arrange the following steps to execute a grounded chat with Azure AI Search in Python. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. First step, initialize an Azure OpenAI chat client with endpoint, API version, and key. Second step, build the prompt system plus user message. Third step, create RAG params with data sources type Azure Search and connection parameters. Fourth step, call chat-client.chat.completions.create with model and extra body equals RAG params. Fifth step, extract response.choices0.message.content and print the grounded reply. Now I'm going to explain why this is the correct order, so the flow of a grounded chat in Python becomes clear. Firstly, the client must be initialized before anything else, because without a configured Azure OpenAI chat client, there is no way to send requests at all. After the client exists, you then build the prompt by combining the system message and the user message, since the model needs clear instructions and a question to respond to. Next, you create RAG params that specify the data sources with type Azure Search, along with connection details, which is what enables grounding on your Azure AI Search Index. Once those parameters are ready, you call chat-client.chat.completions.create, passing the chosen model and attaching RAG params through extra body, so the request actually uses the configured search source. Finally, you read response.choices0.message.content and print it, because that field holds the grounded reply that you want to return to your application or show to the user. Question 9. A team has 2 candidate datasets for fine-tuning a chat model. Dataset A has 120,000 conversations that are highly repetitive with near-duplicate question and answer pairs. Dataset B has 25,000 conversations covering a broad range of intents, edge cases, and phrasings with careful curation. They want more consistent behavior across varied user inputs. Which should they choose? Select one answer. A. Choose dataset A because volume always outweighs diversity. B. Choose dataset B because diverse high-quality examples better generalize across inputs. C. Mix both without cleaning, since the model can learn to ignore duplicates. D. Generate synthetic data to replace both sets because real data is risky. Answer: choose dataset B because diverse high-quality examples better generalize across inputs. Now I'm going to explain why dataset B is the best choice in this situation. Firstly, the goal is consistent behavior across many different kinds of user queries, so the dataset must reflect a wide variety of intents, edge cases, and phrasings rather than repeating the same patterns. Secondly, dataset A mainly adds volume without much new information, and that repetition can cause the model to overfocus on a narrow style of interaction instead of learning to generalize. Moreover, simply mixing both datasets without cleaning would keep a lot of duplicates, which lowers the signal compared to the noise in training. Finally, real data that is properly curated is valuable, so completely replacing it with synthetic examples is unnecessary, which is why the carefully curated and diverse dataset B is the one that best supports generalization across varied user inputs. Question 10. When fine-tuning a chat completion model, how should the amount of training data be determined? Select one answer. A. You should match the token count used in pre-training. B. It depends on the use case. Some goals need more examples to achieve consistent behavior. C. A fixed number is recommended for all use cases. D. Minimal data is always sufficient because the base model already knows everything. Answer: B. It depends on the use case. Some goals need more examples to achieve consistent behavior. Now I'm going to explain why this option is correct and why the others are not as suitable. Firstly, the amount of data needed for fine-tuning varies with the task, its complexity, and how precise you want the model's behavior to be. So different use cases naturally require different numbers of examples. Secondly, matching the huge token count from pre-training is unrealistic and unnecessary because fine-tuning is only adjusting behavior rather than relearning everything. Moreover, there is no single fixed data amount that works for every scenario, so a universal quota would either waste resources or undertrain some tasks. Finally, relying on minimal data just because the base model already has broad knowledge can lead to inconsistent or brittle behavior, whereas tailoring the data volume to the specific goal gives you more reliable and controllable results. Question 11. Which monitoring signals are emphasized as examples of what to collect in production to drive ongoing improvements? Select one answer. A. Usage data and end-user feedback. B. Model hyperparameters and training loss. C. Operating system kernel metrics only. D. /B test IDs without any behavioral data. Answer: A. Usage data and end-user feedback. Now I am going to explain why usage data and end-user feedback are the highlighted monitoring signals for driving improvements in production. Firstly, usage data tells you how people actually interact with the system in real situations, such as which features they use most and where they drop off. So it reveals patterns that you cannot see from training statistics alone. Alongside that, end-user feedback gives direct signals about satisfaction, frustration, and unmet needs, which helps teams prioritize what to refine next in the experience. In contrast, model hyperparameters and training loss are mainly relevant during training and do not reflect how the system behaves once deployed to real users. Similarly, operating system kernel metrics focus on low-level resource behavior rather than user outcomes, so they do not directly guide experience improvements. Finally, /B test IDs without behavioral data simply label experiments but do not say whether users liked or disliked the changes, which is why the combination of usage data and end-user feedback is the key choice for ongoing production improvement. Question 12. Your team wired an index to the chat app using data sources and gets decent answers when users paste exact product IDs. However, when users ask loosely phrased questions, relevant passages are sometimes missed. What change best improves semantic retrieval while keeping the existing setup? Select one answer. A. Increase temperature so responses explore more possibilities. B. Keep keyword search but raise max tokens for the response. C. Set parameters.queryType to vector and add an embedding dependency that names an embedding model deployment. D. Remove extra body and rely solely on the base model training data. Answer: C. Set parameters.queryType to vector and add an embedding dependency that names an embedding model deployment. Now I'm going to explain why this change is the best way to improve retrieval quality in this scenario. First, the problem is that loosely phrased questions do not always match the exact words in the index, so keyword search alone can miss good passages. By switching parameters.queryType to vector and providing an embedding dependency, the system uses embeddings to measure semantic similarity so it can find content that means the same thing even when the wording is different. In contrast, increasing temperature only makes the wording of answers more varied, and raising max tokens just makes answers longer, neither of which improves what documents are retrieved. Finally, removing extra body would disable grounding on the index and force the model to guess from its training data, which usually hurts factual accuracy instead of helping it. Question 13. Which two statements are accurate considerations when choosing a foundation model to fine-tune? Select two answers. A. Model cards can reveal pre-training data that may introduce biases. B. All models shown in the portal can be fine-tuned in any region with any quota. C. Language support varies across models and should be checked for your use case. D. If a model excels at understanding short text, it is automatically best for chat completion. Answers: A. Model cards can reveal pre-training data that may introduce biases. And C. Language support varies across models and should be checked for your use case. Now I'm going to explain why these two are the right considerations when choosing a foundation model to fine-tune. First, model cards often describe what kind of pre-training data was used, such as news articles, code, or broad internet content, so they can highlight where biases or limitations might appear and help you decide whether that model is appropriate for your domain. Furthermore, language support is not identical across models, so if you need strong performance in multiple languages or a specific locale, you must verify that the model actually supports those languages well before investing in fine-tuning. By contrast, not every model in the portal is available to fine-tune in every region or at any quota, since availability depends on regional and capacity constraints. Similarly, a model that is good at short text is not automatically the best for chat completion, because long multi-turn conversations require different capabilities such as memory and coherence over time. Question 14. Fill in the blanks by selecting the correct options. The Semantic Kernel Agents framework is suggested when you need to orchestrate multiple agents, while Copilot Studio Agent Builder is recommended when you want to integrate with Microsoft 365. Now I'm going to explain why these options fit each blank so well. Firstly, the Semantic Kernel Agents framework is designed for coordinating several agents that each handle different tasks, so it is ideal when you need a central place to orchestrate planning, tool use, and conversations across many components. For example, you might have one agent summarizing documents, another calling an external API, and a third enforcing business rules, all working together under this framework. Secondly, Copilot Studio Agent Builder focuses on building copilots that plug directly into Microsoft 365 experiences, such as Teams chats or Outlook add-ins, so it becomes the natural choice when your goal is deep integration with those apps, rather than multi-agent orchestration. Consequently, choosing Semantic Kernel for complex agent coordination and Copilot Studio for Microsoft 365 integration gives you the right tool for each scenario and avoids forcing one product to do a job it was not optimized for. Question 15. For each statement below, indicate whether the answer is true or false. A function called by the agent may contact other APIs or initiate a program. Answer: an Azure Functions integration can use a storage queue for input and another storage queue for output. Answer: an OpenAPI tool uses an OpenAPI 3.0 document so the agent can interact with an HTTP API. Answer: true. Tool invocation is imperative. The developer must explicitly call the function each time. Answer: false. Now I'm going to explain why these true and false choices are correct, so the ideas stay clear. Firstly, when an agent calls a function, that function can run any logic the developer writes, so it can reach out to other APIs or even start a program before returning a result to the agent, which makes the first statement true. Secondly, the Azure Functions example shows a pattern where one storage queue is used to receive input messages and another storage queue is used for output, allowing the function to act as a bridge between queues, so that statement is also true. Next, an OpenAPI tool relies on an OpenAPI 3.0 document that describes endpoints, methods, and schemas, and the agent reads that specification to know how to talk to an HTTP API in a standardized way, which confirms the third statement as true. Finally, Tool invocation is not imperative from the developer's perspective during runtime, because once tools are defined, the agent itself decides when to call them based on prompts and function definitions. So it is declarative rather than the developer manually invoking the function every time, which is why the last statement is false. Question 16. For each benefit of using connected agents, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Eliminates the need for hard-coded logic when routing tasks. Answer: natural language routing. Makes it easier to debug individual parts of a system. Answer: clear separation of responsibilities. Enables adding or swapping roles without redesigning the entire system. Answer: flexible and extensible architecture. Allows building collaborative solutions without complex orchestration. Answer: connected agents. Now I'm going to explain how each benefit lines up with its correct description so the ideas stick clearly. First, eliminating hard-coded routing logic fits natural language routing because the main agent can read the user request and decide in plain language which specialist agent should handle it, instead of relying on rigid if statements scattered through the codebase. Next, debugging becomes easier when there is a clear separation of responsibilities, since each agent owns a focused role, so you can test or fix one agent without disturbing the others. Similar to checking one microservice in a larger application. Furthermore, being able to add or swap roles without redesigning everything reflects a flexible and extensible architecture, where agents are modular components that can be plugged in or replaced as new capabilities are needed. Finally, the ability to build collaborative solutions without writing a custom orchestrator describes connected agents themselves, because the framework lets agents talk to one another and share work, giving you a coordinated system without handcrafting a complex orchestration layer. Question 17. Fill in the blanks by selecting the correct options from the drop-down menus. The handoff orchestration pattern uses a switch case structure to route control between agents based on classification results. Now I'm going to explain how this handoff orchestration pattern works and why these choices fit so well. Firstly, the idea of a switch case structure is that you have one clear decision point where each possible outcome from a classifier maps to a specific branch, so the routing logic stays organized instead of becoming a long chain of if statements. Secondly, the pattern depends on classification results, because an earlier step has already analyzed the user request and turned it into a structured label, such as billing question, technical issue, or sales inquiry, which the switch case can read directly. Consequently, control is handed off to the right specialist agent for that label, allowing each agent to focus on its own role, while the routing remains easy to understand and extend when new categories or agents are added later. Question 18. Fill in the blanks by selecting the correct options from the drop-down menus. A client connects to an A2A agent by first retrieving the agent card from a well-known endpoint, initializing a connection, using that information, and then sending requests to the agent for processing. Now I'm going to explain how each of these pieces fits into the connection flow so it is easy to remember. First, the agent card is like a business card for the agent because it contains the metadata and endpoint details that a client needs before it can talk to the agent at all. Next, that card is discovered at a well-known endpoint, a standard location on the agent server, so every client knows exactly where to look instead of guessing URLs. Once the client has the information from the card, it initializes a connection, which is the live channel that will actually carry messages back and forth between the client and the agent. Finally, over that connection, the client sends requests, which are the structured messages containing roles and content that tell the agent what work to perform and what information to process. Question 19. AI agents can operate in both simple and complex scenarios. In a complex multi-agent setup, what happens when a travel booking agent collaborates with an expenses agent? Select one answer. A. The expenses agent books flights directly and approves travel plans for employees. B. The travel booking agent books flights and hotels, then automatically submits related expense claims to the expenses agent. C. Both agents compete to handle the same user request independently. D. The travel booking agent only provides flight information, leaving hotel booking and expense claims to the employee. Answer: B. The travel booking agent books flights and hotels, then automatically submits related expense claims to the expenses agent. Now I'm going to explain how these two agents work together in this complex scenario. Firstly, the travel booking agent specializes in arranging the trip itself, so it handles tasks like finding suitable flights and hotels and confirming those reservations for the employee. Secondly, once the bookings are made, the same agent already has all the necessary details such as prices, dates, and vendors, so it can automatically package that information into expense claims. Next, those structured claims are sent to the expenses agent, which focuses on processing, validating, and recording the expenses rather than booking travel, so each agent keeps a clear role. Moreover, this collaboration avoids duplication of effort because the expenses agent does not redo the booking work, and the employee does not have to manually type receipts into a separate system. Consequently, the multi-agent setup delivers an end-to-end experience where travel is booked and expense claims are created and submitted automatically, saving time and reducing errors. Question 20. A healthcare startup must generate individualized care plan summaries while ensuring protected patient data is processed by a dedicated component that can be audited separately. They also want to avoid building a custom orchestration layer. Which approach best satisfies these constraints? Select one answer. A. Use a single, generalist agent that performs all steps end-to-end. B. Adopt a custom rules engine to route requests to scripts based on keywords. C. Implement connected agents with a primary agent delegating to a specialized sub-agent that handles sensitive data independently. D. Scale up the existing monolithic agent with more compute to handle privacy and routing concerns. Answer: C. Implement connected agents with a primary agent delegating to a specialized sub-agent that handles sensitive data independently. Now I'm going to explain why this connected agents approach best fits the scenario. Firstly, the requirement to process protected patient data in a dedicated, auditable component is satisfied by the specialized sub-agent, which can be designed with strict logging, access controls, and compliance checks around sensitive information. Secondly, the primary agent focuses on the overall care plan workflow and simply hands off protected segments to that sub-agent, so responsibilities stay clearly separated and easier to audit. Moreover, connected agents rely on natural language routing between agents, which removes the need to build and maintain a custom rules-based orchestration layer, exactly matching the startup's desire to avoid extra orchestration code. By contrast, a single generalist agent or a scaled-up monolithic agent would mix all responsibilities together, making privacy controls and audits harder, while a custom rules engine would reintroduce the orchestration complexity they want to avoid. Consequently, using connected agents with a dedicated sensitive data sub-agent gives both strong privacy handling and maintainable routing in one design. Question 21. For each statement below, indicate whether the answer is true or false. The Azure AI Agent client manages connections to Azure AI Foundry projects. Answer: Chat Agent defines tools and instructions for agent behavior. Answer: Agent thread requires manual tracking of conversation state by developers. False. Azure AI Foundry Agent supports built-in tools like code interpreter and file search. And true. Now I'm going to explain why each of these statements has that true or false value, so you can link them to how agents work in Azure AI Foundry. Firstly, the Azure AI Agent client really does manage the secure connection and access layer to Azure AI Foundry resources, So it is correct to say it manages connections to projects. Secondly, Chat Agent is where you define tools and instructions, which shape how the agent communicates, what functions it can call, and how it behaves. So that statement is also true. Next, the idea that Agent Thread requires manual tracking of conversation state is false because Agent Thread automatically maintains conversation history for you, removing the need for developers to store and pass messages around by hand. Finally, Azure AI Foundry Agent includes built-in tools such as a code interpreter, file search, and even web search, available out of the box. So the statement about supporting built-in tools like code interpreter and file search is true as well. Question 22. A design firm uses 3 AI agents to debate logo ideas, with a human creative director moderating. The director can step in any time to guide the discussion. Which orchestration pattern best fits this setup? Select one answer. A. Concurrent orchestration. B. Group chat orchestration. C. Sequential orchestration. D. Handoff orchestration. Answer B. Group orchestration. B. I will walk through why group chat orchestration is the best match for this scenario. Firstly, the setup describes multiple AI agents talking with each other about logo ideas, while a human creative director can join or steer the discussion at any moment. And that is exactly what group chat orchestration is designed for: a shared conversational space with optional human participation and centralized flow management. Secondly, concurrent orchestration would run agents in parallel without them really interacting in a single conversation, so it would not feel like a live debate guided by the director. Likewise, sequential orchestration would trigger agents one after another in a fixed order, more like a pipeline than a collaborative brainstorming session. Finally, handoff orchestration focuses on passing control from one agent to another based on routing rules, not on maintaining an ongoing group dialogue, so it does not reflect the described roundtable discussion. Whereas group chat orchestration naturally supports this multi-agent human-in-the-loop creative workshop. Question 23. Arrange the following steps that occur when an agent executor processes a request in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. First step, the executor receives a request. Second step, the executor calls the agent's core logic to process the task. Third step, the executor wraps the result as an event. Fourth step, the event is placed on the event queue. Fifth step, the routing mechanism sends the event to the requester. Now I'm going to explain how this flow works from beginning to end, so the sequence is easy to remember. Firstly, everything starts when the executor receives a request, because there is nothing to process until some caller sends work in. Next, the executor immediately calls the agent's core logic, so the actual reasoning or computation for that request can be performed and a result can be produced. Once that core logic finishes, the executor wraps the result as an event, turning the raw output into a standard event object that the rest of the system understands. Afterwards, the event is placed on the event queue, which acts like a mailbox where processed results wait safely until they can be delivered. Finally, the routing mechanism takes that queued event and sends it back to the original requester, completing the round trip from incoming request to returned response in a clear, reliable order. Question 24. What is a major advantage of offering multiple custom tool options, such as function calling, Azure Functions, Open API specification tools, and Azure Logic apps? Select one answer. A. They require complex high-code implementations for every scenario. B. They eliminate the need for interoperability with existing systems and web services. C. They provide flexibility to integrate custom functionality in multiple ways, enabling broad extensibility. D. They restrict agent capabilities to a single integration method for consistency. Answer: C. They provide flexibility to integrate custom functionality in multiple ways, enabling broad extensibility. Now I'm going to explain why option C is the correct advantage and why the others do not fit. Firstly, having several custom tool options means agents can plug into many kinds of systems, from simple HTTP APIs described by OpenAPI to event-driven flows and logic apps, to code-based Azure functions, so teams can choose the integration style that matches each scenario instead of being forced into one pattern. In addition, this flexibility gives broad extensibility because as new services or workflows appear, you can wire them in using whichever tool type is most natural, rather than rewriting everything around a single rigid interface. By contrast, saying these options require complex high code for every scenario is misleading, since tools like logic apps and functions actually reduce boilerplate and let you move faster with low-code or serverless patterns. Similarly, they do not eliminate the need for interoperability. They actively enhance it by making it easier to connect to existing web services and enterprise systems. Finally, they certainly do not restrict agents to one integration method. In fact, the whole point is the opposite, to provide multiple integration paths, so your solution stays adaptable as requirements evolve. Question 25. Which two outcomes are direct benefits of dynamic tool discovery with an MCP server? Select two answers. A. Agents can always use the latest version of a tool without modifying agent code. B. The need for any server component is removed permanently. C. Tool management overhead shifts from the agent into a centralized service. D. All external services become unnecessary once tools are discovered. Answers. A. Agents can always use the latest version of a tool without modifying agent code. And C. Tool management overhead shifts from the agent into a centralized service. Now let us walk through why these two outcomes are the direct benefits of dynamic tool discovery. Firstly, when tools are discovered dynamically from an MCP server at runtime, the agent simply fetches the current tool definitions so it can immediately use the latest version without any change to its own code, which makes updates safer and more agile. Secondly, that same MCP server becomes the central catalog for tools, so the work of registering, updating, and organizing tools moves out of each individual agent and into a single centralized service, thereby reducing duplication and management overhead. However, an MCP server is still a server component, so it does not remove the need for servers entirely, and external services are still required, because tools are merely the interfaces that connect agents to those services, not replacements for them. Question 26. Which conditions make sequential orchestration the best choice for a workflow? Select two answers. A. Tasks can be performed in parallel to save time. B. Each stage depends on the result from the previous stage. C. The workflow must follow a strict order of execution. D. Agents need to dynamically collaborate and share control. Answers. B. Each stage depends on the result from the previous stage. And C. The workflow must follow a strict order of execution. Now I'm going to explain why these two conditions point to sequential orchestration as the right pattern. Firstly, when each stage depends on the result from the previous stage, you cannot safely run tasks in parallel, so a step-by-step flow ensures that each agent receives the fully processed output it needs before continuing. Secondly, a workflow that must follow a strict order of execution benefits from sequential orchestration because this pattern enforces a predictable, fixed sequence, much like following numbered instructions in a medical procedure or a loan approval pipeline. Meanwhile, conditions like running tasks in parallel are better handled by concurrent orchestration. And situations where agents dynamically collaborate and share control fit patterns like group chat or handoff orchestration rather than a rigid sequence. Question 27. Which statement best explains how the A2A agent server functions within a hosted system? Select one answer. A. It acts as a bridge between the agent's logic and external systems. B. It replaces the agent executor as the main task processor. C. It directly manages model training and skill definition. D. It stores the agent's state permanently in a database. Answer. A. It acts as a bridge between the agent's logic and external systems. Now let us talk through why option A is the best description. The A2A agent server's main job is to sit between the agent's internal logic and the outside world, exposing HTTP endpoints so clients and other agents can send requests and receive responses. The actual thinking and task execution still happen inside the agent executor, so the server does not replace that core processor, which is why option B is not accurate. Likewise, model training and skill definition live in the agent configuration and code, not in the hosting server itself, so option C overstates its role. Option D is also misleading because long-term persistence of state is typically handled by dedicated storage services, not by the A2A server directly. Therefore, the clearest and most accurate summary is that the A2A agent server acts as a bridge connecting agent logic to external systems. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. A multi-turn conversation helps obtain additional details from a user by defining follow-up prompts that may link to existing answers or create new ones. Now I'm going to explain how all of these pieces work together in practice. First, a multi-turn conversation is simply an ongoing dialogue where the system does not stop after the first reply, but keeps talking with the user, asking for more details whenever something is unclear or incomplete. In that dialogue, follow-up prompts are the clarifying questions the system asks, such as, do you prefer weekdays or weekends? After someone says they want to schedule an appointment, and these prompts refine the user's intent step by step. As the conversation continues, the assistant can link to existing answers, reusing information it already provided earlier, for example, referring back to a previously suggested plan instead of starting from scratch every time. Finally, if the user introduces a completely new need, the system can create new ones, generating fresh answers that extend the conversation while still staying anchored in what has already been discussed, which is what makes multi-turn interactions feel natural and helpful. Question 29. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure AI Language Service provides pre-configured features that require no model training and learned features that rely on labeled data and model deployment. Now I'm going to explain what this sentence is really telling us about Azure AI Language. Firstly, pre-configured features are ready to use out of the box. For example, sentiment analysis or summarization, so you can call them immediately without collecting data or training your own model. Secondly, learned features are different because you must supply labeled examples, train a model, and then deploy it, which lets the service adapt to very specific categories or business concepts that do not exist in the standard features. Consequently, Azure AI Language gives you a flexible mix, quick wins with pre-configured features when you just need common language skills, and deeper customization through learned features when your scenario demands domain-specific understanding. Question 30. For each speech-to-text feature, drag it to the correct description. Each item may be used once, more than once, or not at all. Provides instant transcription with intermediate results for live audio inputs. Answer: real-time transcription. Offers the fastest synchronous output where latency must be predictable. Answer: fast transcription. Enables efficient processing of pre-recorded audio at scale. Answer: batch transcription. Improves accuracy for specific domains or noisy conditions. Answer: custom speech. Now I am going to explain how each speech-to-text feature lines up with its description so you can quickly recognize them in exams and real projects. First, real-time transcription is designed for live audio streams, so it delivers text as the user is speaking and even updates intermediate results, which matches the idea of instant transcription for live inputs. Next, fast transcription focuses on giving the quickest possible synchronous response. So when an application needs predictable low latency, such as dictation in a form, this option fits perfectly. Furthermore, batch transcription is optimized for large pre-recorded data sets, like hours of call center recordings, which is why it is associated with efficient processing of audio at scale rather than low latency per request. Finally, custom speech lets you train the service on domain-specific vocabulary or noisy environments, for example, medical terms or factory background noise, so it directly improves accuracy for those special domains and challenging acoustic conditions. Question 31. Fill in the blanks by selecting the correct options from the drop-down menus. When translating speech, the speech translation config defines both the recognition language and the target languages for translation. Now I'm going to explain how these pieces work together when you build a speech translation app. Firstly, speech translation config is the object you use to set up all the important configuration for translation, including which languages are involved and how the service should connect. Secondly, the recognition language is the language of the incoming audio. For example, English if the user is speaking English, and setting it correctly helps the service understand pronunciation and grammar more accurately. Moreover, the target languages setting lets you choose one or more output languages, such as Spanish or French, so the same spoken input can be translated into several texts or voices at once if you want. Finally, by defining both recognition language and target languages inside speech translation config, you keep the whole translation pipeline controlled from a single place, which makes your code easier to manage and your translations more reliable across different scenarios. Question 32. For each Azure AI Speech SDK element, drag it to its correct function in the correct match column. Each item may be used once, more than once, or not at all. Specifies the desired voice for translated speech. Translation config captures and streams audio output during real-time translation. Translation recognizer dot synthesizing event retrieves the translated audio byte stream from the result. Result.getAudio left parentheses, right parenthesis converts translated text into audio for each target language. Speech synthesizer triggers when a new segment of translated audio is ready. Synthesizing event handler. Now I'm going to explain how each SDK element lines up with its role so you can picture the full pipeline. Firstly, translation config is where you define parameters for translated speech, including which output voice to use, so it naturally matches specifying the desired voice for translated speech. Secondly, translation recognizer.synthesizing event is the hook that actually starts streaming translated audio as it is produced, which is why it captures and streams audio output during real-time translation. Next, once an event arrives, result.getAudio left parentheses, right parenthesis is called to pull out the raw byte stream of that translated audio segment. After that, speech synthesizer is responsible for turning translated text into spoken audio during manual synthesis scenarios, so it fits the description of converting translated text into audio for each target language. Finally, the synthesizing event handler is the piece of code you write that runs whenever a new audio segment is ready, reacting to the event and processing or playing the audio as needed, while other pieces like the translations dictionary are not part of this event-based streaming flow. Question 33. For each statement below, indicate whether it is true or false. Named entity recognition groups detected items into categories such as person, location, and organization. Answer: true. The subcategory field provides more specific detail within a main category. True. The offset value represents the total number of characters in the entity. Answer: false. Each entity result includes a confidence score indicating how certain the model is. Answer: true. Now, I'm going to explain each of these statements so you see how named entity recognition results are structured. Firstly, named entity recognition really does group detected text spans into high-level categories like person, location, and organization, which helps you quickly understand what type of information was found in the text. Secondly, The subcategory field adds an extra layer of detail within that main category. For example, marking a location more specifically as a city or a country. So this statement is also true. In contrast, the offset value does not measure how many characters are in the entity. Instead, it marks the character position where the entity begins in the original text, so saying it represents the total number of characters is false. Finally, each entity comes with a confidence score, which is a numeric value showing how confident the model is in its classification. And higher scores mean the model is more certain about that particular entity. Question 34. A customer service bot often misinterprets user questions because they are vague. The development team wants to improve accuracy by asking clarifying questions before providing answers. Which feature should they use? Select one answer. A. Multi-turn conversation. B. Static question-answer pairs. C. Language understanding intents. D. Sentiment analysis. Answer. Multi-turn conversation. I am now going to explain why multi-turn conversation is the right feature here. Firstly, the core problem is that user questions are vague, so the bot needs a way to ask follow-up questions before deciding on a final answer. And multi-turn conversation is designed exactly for that kind of back-and-forth clarification. Secondly, this feature lets the system refine the user's intent over several turns. For example, asking, "Which product are you asking about?" Or, "Is this for a refund or an exchange?" So the final response is more accurate and relevant. By contrast, language understanding intents can label the initial request, but does not automatically prompt the user for more detail. Static question-answer pairs just give one-shot answers with no follow-up, and sentiment analysis only measures tone, not meaning. Therefore, using multi-turn conversation directly addresses the need to ask clarifying questions and improves the bot's accuracy with ambiguous queries. Question 35. A developer sends a request to a knowledge base using the REST interface and wants only answers labeled with a specific category of API. Which properties should they include in the request? Select one answer. A. Top. B. Metadata. C. Score threshold. D. Strict filters. Answer. Strict filters. Now let us walk through why strict filters is the right choice here. Fine. When a developer needs only answers that match a specific category, such as API, they must filter based on metadata attached to each answer, not just on score or count. The strict filters property is designed exactly for this because it lets you specify key value metadata pairs, so the service will return only those entries whose metadata matches those filters. For example, category equals API. In contrast, top simply controls how many answers come back, so it might still include other categories if they score highly. Similarly, score threshold only affects confidence levels by dropping answers below a certain score, but it does not know anything about categories in the metadata. Finally, metadata itself appears in the response as descriptive information and is not a request property you set for filtering, so it cannot enforce the API category requirement, whereas strict filters directly applies that metadata constraint in the request. Question 36. Arrange the following steps in the correct sequence for the model lifecycle. Instruction. Drag and drop the items into the correct order, starting with the first step. First step, train. Second step, test. Third step, deploy, publish. Fourth step, review. Now I'm going to explain how these steps flow together in the model lifecycle. Firstly, you start with train, where the model learns patterns from labeled data and begins to form its understanding of tasks like classification or intent detection. Next, you move to test, using separate validation data to check accuracy, find weaknesses, and make sure the model performs well before anyone relies on it. After that, once the results are acceptable, you deploy and publish the model so real users and applications can call it in production, similar to releasing a new app version to customers. Finally, you enter the review stage, continuously monitoring performance, collecting feedback, and deciding when to retrain or fine-tune so the model stays accurate as data and requirements change over time. Question 37. For each statement below, indicate whether it is true or false. There are multiple supported output formats for speech synthesis audio. Answer: true. All supported audio formats have the same sample rate. False. Voice configuration and audio format can be customized independently. True. The speech synthesis voice name property defines the output bit depth. Answer: false. Now I'm going to explain why each of these statements is marked true or false so they are easy to remember. Firstly, the service really does offer multiple output formats for speech synthesis audio, such as different codecs and containers, so developers can choose what best suits their playback or storage needs, which makes the first statement true. However, those formats do not all share the same sample rate or encoding settings, so it is false to claim they are identical in that regard. Different formats are tuned for different quality and performance trade-offs. Furthermore, voice configuration, such as which voice is used and its style, is configured separately from the audio format, like sample rate and encoding, so you can change one without affecting the other, which is why the third statement is true. Finally, the speech synthesis voice name property simply tells the system which voice to use, for example, a specific language and persona, and it does not control low-level audio parameters like bit depth, so the last statement is false. Question 38. A travel agency uses question answering to help customers cancel reservations. When a user asks, "How can I cancel a reservation?" the system needs to ask whether the reservation is for a flight or a hotel before providing a final answer. What feature should the agency implement to handle this clarification? Select one answer. Static single-turn answers. B. Entity extraction in the Azure bot service. C. Automated speech transcription. D. Multi-turn conversation with follow-up prompts. The correct answer is D. Multi-turn conversation with follow-up prompts. Now that we've gone through the question and the correct answer, let's move into the explanation. First, the scenario requires the system to request more details before giving a final response, and that is exactly what a multi-turn conversation provides. It allows the question answering model to ask follow-up questions whenever the original query is incomplete. Secondly, static single-turn answers would not work because they can only give straightforward responses without asking for clarification. Therefore, they cannot support a situation that requires additional questions. Moreover, entity extraction in the Azure bot service is helpful for identifying keywords inside user input, but it does not drive back-and-forth clarification by itself, so it cannot resolve this type of ambiguity. Finally, automated speech transcription is unrelated here because the issue is not about converting speech to text, but rather about guiding users through a structured dialogue to gather the missing information. Consequently, multi-turn conversation is the only feature that enables a natural, guided clarification process, similar to how a human agent would ask, "Is this for a flight or a hotel?" before proceeding. Question 39. From where can a knowledge base be deployed after successful testing and training? Select one answer. A. From Azure Virtual Machines. B. From Microsoft Entra ID. C. Directly from Language Studio. D. From the Azure AI Search Index. The correct answer is C. Directly from Language Studio. Now that we've reviewed the question and the correct answer, let's move into the explanation. To begin with, once a knowledge base has been tested and trained successfully, Language Studio provides a built-in option to publish it directly. This makes deployment simple and immediate because the platform already contains the tools needed to expose the knowledge base as a REST endpoint. Meanwhile, Azure Virtual Machines do not serve as hosting or publishing mechanisms for knowledge bases. Instead, they are general-purpose compute resources, so they do not provide the deployment functionality required here. Additionally, Microsoft Entra ID handles authentication and identity management, not model publishing, so it cannot deploy a knowledge base either. Finally, the Azure AI Search Index is used for indexing and searching content, not for deploying question-answering knowledge bases, which means it cannot serve as the publishing source. Consequently, the only option that supports direct deployment after training is Language Studio itself. Question 40. A home automation engineer builds a conversational model that recognizes commands like turn on the kitchen light and turn on the fan. They want the same pattern to work for all devices without retraining for each one. What feature allows this flexibility? Select one answer. A. Creating a separate intent for every device. B. Patterns that use entity placeholders such as brace, device name brace. C. Adding synonyms for each device name in a list entity. D. Removing punctuation from all utterances. Answer B. Patterns that use entity placeholders, such as brace, device name brace. Now I am going to explain why using an entity placeholder is the right choice here. First, the engineer wants a single command pattern, like turn on the brace, device name brace, to cover many devices such as kitchen light, fan, heater, and so on, and an entity placeholder lets the model treat that device name as a variable rather than a fixed word. Consequently, the intent stays exactly the same, while the device name entity can take on many values, so you avoid creating and maintaining a separate intent for every device, which would quickly become messy and hard to generalize. Moreover, adding synonyms in a list entity helps the model recognize different names for a device, like living room lamp versus sofa light, but it still relies on the underlying pattern, turn on the brace, device name brace. So synonyms alone do not give you the reusable structure described in the question. Likewise, removing punctuation from all utterances does not create any generalization. It just risks making the text harder for the model to parse cleanly. Therefore, patterns that use entity placeholders, such as brace, device name brace, provide the flexibility to reuse one pattern across all devices without retraining for each individual one. Question 41. The field multilingual in the Azure AI language project metadata primarily indicates that select one answer. A. The model is restricted to English only. B. The SDK automatically translates labels into English. C. The model supports input documents in multiple languages. D. The JSON request includes translations for every class. Answer C. The model supports input documents in multiple languages. Now, let us clarify what this multilingual field really tells us. When multilingual is set to true, it means the project can handle and train on text that comes in more than one language. So the model is designed to accept multilingual input rather than just a single language. Consequently, option C is correct because it directly describes that capability to support input documents in multiple languages. In contrast, option A is the opposite of what the flag does, since restricting the model to English only would be a non-multilingual setup. Moreover, option B is incorrect because the SDK does not magically translate labels into English. You still manage your labels yourself, regardless of this flag. Finally, option D is wrong because the JSON request does not automatically include translations for every class. The multilingual field simply enables the model to work with several languages. It does not embed translation data into the request structure. Question 42. What is the primary role of the speech config object when working with Azure AI Speech through an SDK? Select one answer. A. Monitors portal usage statistics for speech workloads. B. Stores transcribed text output for later retrieval. C. Defines the connection to the speech resource by holding configuration details such as key and region. D. Provides the graphical interface for editing audio models. Answer. C. Defines the connection to the speech resource by holding configuration details such as key and region. Now I'm going to explain why option C is correct and why the others do not describe speech config accurately. Firstly, speech config is the core configuration object that tells the SDK which speech resource to talk to. so it holds essential details like the subscription key and the Azure region. And every recognizer or synthesizer you create depends on this connection information. Because of that, it makes sense that its primary role is to define the connection to the speech resource, rather than handling data storage or user interfaces. By contrast, monitoring portal usage statistics is done in the Azure portal and related telemetry tools, not inside Speech Config, so option A is incorrect. Similarly, storing transcribed text for later retrieval is an application concern, meaning your own code or database handles that, so option B does not match what this configuration object does. Finally, there is no graphical interface built into Speech Config at all. It is purely a code-level configuration class, so option D is also wrong, leaving option C as the accurate description of Speech Config's main purpose. Question 43. Which Azure resource is responsible for hosting the knowledge base index in a question-answering solution? Select one answer. A. Azure Cognitive Services Translator. B. Azure AI Search. C. Azure SQL Database. D. Azure Blob Storage. B. Azure AI Search. Now, let us walk through why Azure AI Search is the correct choice here. First of all, a knowledge base index needs a search engine that can store, rank, and retrieve question and answer pairs efficiently. And Azure AI Search is exactly the service designed to host these searchable indexes for fast semantic lookup. By contrast, Azure SQL Database focuses on relational tables and structured queries, which is great for business data, but not optimized for text search over a knowledge base in the same way. Similarly, Azure Blob Storage is mainly for holding raw files like PDFs or JSON blobs, so it does not provide the indexing and scoring capabilities required for question answering. Finally, Azure Cognitive Services Translator is used to translate text between languages rather than to index and search content, so it cannot act as the knowledge base index host, which is why Azure AI Search is the resource responsible for that role in this solution. Question 44. Which statement best describes the relationship between the Azure AI Language REST API and its SDKs? Select one answer. A. The REST API is the core service, and SDKs are abstractions built on top of it. B. The SDKs replace the REST API entirely with a different architecture. C. The REST API and SDKs operate as unrelated products. D. SDKs are required before any REST API can be called. Answer A. The REST API is the core service, and SDKs are abstractions built on top of it. Now I'm going to explain how the REST API and SDKs relate to each other in practice. First of all, the REST API is the fundamental service that exposes endpoints for Azure AI Language, and every request ultimately goes through those HTTP calls, whether you send them directly or not. Consequently, SDKs simply act as language-specific wrappers around that same REST API, giving you convenience methods, models, and error handling, so you do not have to manually craft HTTP requests in C#, Python, or JavaScript. By contrast, they do not replace the REST API with a new architecture. Rather, they depend on it under the hood, much like a mobile banking app depends on the bank's core servers. Likewise, it would be wrong to say the REST API and SDKs are unrelated products, because the SDKs are built specifically to talk to those REST endpoints and nothing else. Finally, you can call the REST API directly with tools like curl or Postman without installing any SDK at all, so SDKs are helpful but not required, which confirms that option A is the only statement that accurately describes their relationship. Question 45. You're developing an audio-enabled chatbot. The model is deployed in Azure and needs to receive prompts containing both text and audio. You want to use a supported SDK instead of calling REST APIs directly. Which SDKs can be used for this task? Select one answer. A. Python or .NET SDKs for Azure AI, Model Inference, or OpenAI. B. JavaScript SDK for Azure Blob Storage. C. PowerShell SDK for Azure Functions. D. SQL Data SDK. Answer A. Python or .NET SDKs for Azure AI, Model Inference, or OpenAI. Now let us walk through why option A is the correct choice here. First, an audio-enabled chatbot that sends both text and audio to a deployed model needs an SDK that actually talks to Azure AI Model Inference or OpenAI, including support for multimodal prompts like text plus audio files or streams. The Python and .NET SDKs are designed exactly for this. They wrap the REST endpoints for these models and expose friendly methods to send messages, attach audio, and handle responses without you manually building HTTP requests. Meanwhile, the JavaScript SDK for Azure Blob Storage is focused on file storage only, so it can upload or download audio files, but cannot directly interact with the chat model or send prompts to it. Likewise, the PowerShell SDK for Azure Functions is aimed at automating and managing serverless functions, not invoking AI model inference in a conversational flow. Finally, the SQL Data SDK is about working with databases, so it manages queries and data access rather than multimodal model input and output. Therefore, when you want a supported SDK to drive an audio-enabled chatbot against a deployed Azure model, the Python or .NET SDKs for Azure AI Model Inference or OpenAI are the right tools to use. Question 46. When embedding binary audio data directly in a prompt using a data URL, which MIME type identifies the audio format? Select one answer. A. Audio MP3. B. Text plain, see application JSON. D. Audio WAV. A. Audio MP3. Now let us walk through why audio/MP3 is the correct MIME type here. First, when you embed binary audio directly in a data URL, the part before the semicolon tells the system what kind of file it is. So data audio MP3 base64 immediately signals that the bytes are an MP3 audio stream rather than some other media type. Because of that, any client or SDK reading the data URL can decode the base64 and hand it off to an MP3 decoder, which makes audio MP3 the accurate MIME type for MP3 files. By contrast, text plain is used for plain text content, such as simple messages or logs, so using it for binary audio would mislead the decoder and typically break playback. Likewise, application JSON describes JSON-structured text, which is perfect for configuration or payload objects, but it does not identify any audio format at all. Finally, audio WAV does represent audio, yet it specifically refers to WAV files, not MP3 encoding, so it would only be correct if the embedded data were a WAV, not an MP3, which is why audio MP3 is the one MIME type that correctly identifies the MP3 audio format in a data URL. Question 47. For each principle in face-based AI solutions, drag it to the correct description. Each item may be used once, more than once, or not at all. Treat facial data as sensitive and protect it during training and inferencing. Data privacy and security. Tell people how their facial data is used and who can access it. Transparency. Prevent designs or uses that unfairly target or disadvantage people based on appearance, fairness, and inclusiveness. Now I'm going to explain why each description matches its principles so clearly. First, treating facial data as sensitive and protecting it during both training and inferencing belongs under data privacy and security, because faces are personally identifiable and must be safeguarded wherever the data flows, from storage through to model use. Secondly, telling people how their facial data is used and who can access it is the essence of transparency, since it ensures users are informed and can make meaningful choices about participating in facial recognition or analysis systems. Finally, preventing designs or uses that unfairly target or disadvantage people based on appearance aligns with fairness and inclusiveness, as responsible face-based AI must avoid prejudicial decisions and must not reinforce discrimination against any group. Question 48. Fill in the blanks by selecting the correct options from the drop-down menus. To recognize internal team members by face, configure a custom people model after obtaining limited access approval. To ensure internal jargon appears correctly in transcripts, train a custom language model. To flag product and company names, train a custom brands model. Now let us talk through why each of these choices fits so well. First, Recognizing internal team members by face goes beyond generic face detection, so you need a custom people model that is trained on images of your own staff. And because this involves sensitive biometric data, you must first obtain limited access approval to meet responsible AI requirements. Next, when the goal is to capture internal jargon accurately in transcripts, such as project code names or domain-specific terms, a custom language model is the right fit because it learns organization-specific vocabulary and pronunciation, improving transcription quality for those unique phrases. Finally, when you want the system to highlight product names and company names in videos or images, a custom brands model is used, since it is designed to recognize specific logos or brand text you have trained it on, making it ideal for tracking brand presence across your content. Question 49. Arrange the steps to consume the Video Indexer REST API in a backend service. Instruction: drag and drop the items into the correct order, starting with the first step at the top. First step: request an access token using the auth endpoint. Second step: call a REST endpoint with the token. Third step: parse the JSON response. Fourth step: use the parsed insights in your app or store them. Now I'm going to explain why this sequence is the correct way to work with the Video Indexer REST API in a backend service. To begin with, you must request an access token using the auth endpoint, because the API will only accept calls that include a valid token for authentication and authorization. Once you have that token, you then call a REST endpoint, such as videos or insights, attaching the token in your request headers so the service knows who you are and allows the operation. After the service responds, the result arrives as a JSON payload. So the next step is to parse the JSON response to pull out useful fields like video ID, insights, or processing state. Finally, when you have those parsed values, you use the parsed insights in your app or store them. For example, updating a database, driving search, or powering a dashboard, completing the full flow from secure call to actionable data. Question 50. A model that can interpret visual input and generate responses based on that visual context is best described as which of the following? Select one answer. A. Text-only large language model. B. Vision-enabled generative AI model. C. Data warehouse service. D. Virtual machine image. B. Vision-enabled generative AI model. Now let us go through why this is the correct description. A model that can look at an image, understand what is in it, and then generate a response that uses that visual information is doing more than text processing. It is combining vision and generation, so we call it a vision-enabled generative AI model, meaning it accepts visual input such as images alongside text and then produces answers, captions, or reasoning that depend on what it sees. A text-only large language model, in contrast, only reads and writes text. If you give it an image directly, it has no built-in way to interpret pixels, so it cannot truly ground its answers in visual context. A data warehouse service is focused on storing and analyzing structured data, not on understanding pictures or generating natural language from them. A virtual machine image is simply a template for running servers or applications in the cloud and has nothing to do with the model's ability to interpret vision. Therefore, the only option that accurately captures a model that understands images and generates responses based on them is a vision-enabled generative AI model. Question 51. For each statement below, indicate whether the answer is true or false. If quality is omitted from the request, the model defaults to standard, true. If style is omitted, it defaults to natural, false. The size parameter determines the resolution of the generated image, true. The image returned from a DAL-E3 request is a PNG file, true. Now let us walk through why each of these is marked this way. Firstly, when you leave out the quality setting, the image generation service assumes standard quality, so the first statement is correct because standard is the default level of quality applied to the request. Secondly, if you do not specify any style, the system does not revert to a plain natural look. Instead, it defaults to a vivid style that is more colorful and stylized, which makes the second statement false because it names the wrong default. Next, the size parameter directly controls the output dimensions of the image, such as requesting 1024 by 1024 pixels. So naturally, that statement is true, since size is what defines the resolution you receive. Finally, when DAL-E3 generates an image and returns a URL, the underlying file type at that address is a PNG image. So the last statement is true because the downloaded file is indeed in PNG format by default. Question 52. Which authentication methods are supported for client applications connecting to an Azure AI Vision resource? Select two answers. A. Key-based authentication using an authorization key. Correct. B. SSH key pair exchange to the endpoint. C. Microsoft Entra ID authentication. Correct. D. Personal access tokens issued for Azure DevOps. Now let us go through why A and C are the supported methods for Azure AI Vision. First, Azure AI Vision is an Azure resource, so it follows the common Azure pattern of allowing either key-based authentication or token-based authentication through Microsoft Entra ID. With key-based authentication, the client sends one of the resource's authorization keys in the request header, and as long as that key is valid, the Vision endpoint accepts the call and processes the image or video operation. Furthermore, Microsoft Entra ID authentication lets you obtain an access token, for example, using a managed identity or a service principal, and then attach that bearer token when calling the Vision API, which is especially useful in production where you want to avoid storing long-lived keys. However, SSH key pair exchange is used for secure shell connections to virtual machines or similar endpoints, not for calling REST-based cognitive services, so option B does not apply here. Likewise, personal access tokens are specific to Azure DevOps to secure repos and pipelines, and they are not recognized by Azure AI Vision as an authentication mechanism, so option D is not supported. Consequently, the only valid choices for authenticating client applications with Azure AI Vision are key-based authentication using an authorization key and Microsoft Entra ID authentication. Question 53. Your DAM team wants to auto-generate image thumbnails that keep the subject centered for various aspect ratios 1:1 and 16:9 without manual cropping. Which Azure service feature addresses this need? Select one answer. A. Azure AI Content, Understanding Custom Analyzer. B. Azure AI Vision, Smart Crop Thumbnails. C. Azure AI Document Intelligence Table Extraction. D. Azure AI Translator Bilingual Dictionaries. Answer B. Azure AI Vision Smart Crop Thumbnails. Now let us explain why Smart Crop Thumbnails is the right feature here. First, the requirement is to automatically create thumbnails that keep the main subject centered even when the aspect ratio changes. And Azure AI Vision Smart Crop Thumbnails are designed exactly for this, because the service analyzes the image, finds the region of interest, and computes crop boxes for each requested size, so the important content stays in view. In contrast, a Content Understanding Custom Analyzer focuses on extracting custom fields or insights from media, but does not perform automatic cropping to different aspect ratios. Document Intelligence Table Extraction is aimed at finding tables inside scanned documents, which helps with structured data, but has nothing to do with image thumbnails for a DAM system. Azure AI Translator Bilingual Dictionaries provide translation resources for language scenarios, so they are completely unrelated to visual cropping needs. Therefore, to generate centered thumbnails across multiple aspect ratios without manual effort, Azure AI Vision Smart Crop Thumbnails is the feature that directly satisfies this requirement. Question 54. How do users authenticate to the Azure AI Custom Vision portal at customvision.ai? A. By creating a separate Custom Vision only username and password unrelated to Azure. B. By signing in with Azure credentials associated with their subscription. C. By uploading SSH public keys on first login. D. By using a local machine account created during SDK installation. Answer: B. by signing in with Azure credentials associated with their subscription. Here is why this is the correct method. The Custom Vision portal is tightly integrated with Azure Identity and Subscriptions, so when you go to customvision.ai, you authenticate using the same Azure account that owns or has access to the relevant subscription and resource group. This Azure sign-in allows the portal to read your permissions and connect to your existing resources without you needing a separate product-specific login. In contrast, creating a separate Custom Vision-only username and password is not supported because identity management is centralized through Azure instead of a custom account system. Uploading SSH public keys is something you might do for virtual machines or other infrastructure that supports SSH, not for logging into a web portal like Custom Vision. Likewise, a local machine account created during SDK installation is simply an operating system user and has nothing to do with authenticating to the online service. Therefore, users authenticate to the Azure AI Custom Vision portal by signing in with their Azure credentials tied to their subscription. Question 55. A medical organization wants to automate patient form intake by reading handwritten and printed fields, including checkboxes and tables, while maintaining accuracy without building its own AI models. Which Azure Document Intelligence component should they use? Select one answer. A. Pre-built model. B. Custom model. C. Document analysis model. D. Azure OpenAI service. A. Pre-built model. Now let's explain why the pre-built model is the right choice here. The scenario describes common patient forms that include printed text, handwriting, checkboxes, and tables, and the organization explicitly does not want to build and train its own AI models. Pre-built models in Azure Document Intelligence are designed exactly for this situation because they are ready-made models that already know how to read typical forms and extract structured data automatically from both printed and handwritten inputs. By contrast, a custom model would require collecting labeled examples of the organization's forms and training a model specifically for them, which adds extra time and effort that the question says they want to avoid. A general document analysis model can detect structure like lines and paragraphs, but does not provide the rich, form-specific field extraction this intake workflow needs. Azure OpenAI service focuses on language generation and conversation, not on high-accuracy OCR and structured data extraction from scanned forms. Therefore, choosing the Azure Document Intelligence pre-built model gives the medical organization accurate automated form processing with minimal setup, matching the requirements in the question perfectly. Question 56. For each statement, indicate whether it is true or false. Azure Document Intelligence is part of Azure AI services. True. OCR capabilities are used to extract handwritten text, but not printed text. False. Bounding boxes define the positions of detected text in relation to a page. True. Azure Document Intelligence supports only PDF files. False. Now I will briefly explain each decision. First, Azure Document Intelligence is indeed part of Azure AI services as a cloud-based offering under the Azure AI umbrella, so the first statement is true. Second, OCR in Azure Document Intelligence is capable of extracting both printed and handwritten text, not only handwriting, so the second statement claiming it does not handle printed text is false. Third, bounding boxes are coordinate rectangles around detected text elements, which specify where pieces of text lie on the page or image, so the third statement is correct. Finally, Azure Document Intelligence can process several file types, including images such as JPEG and PNG, as well as PDFs and TIFFs, so it does far more than PDF only, making the fourth statement false. Question 57. Fill in the blanks by selecting the correct options from the drop-down menus. To extract data from multiple Azure AI services under a single endpoint, create an Azure AI Services resource. To use Microsoft Entra authentication with a single service, create an Azure Document Intelligence resource. Now I will explain why each resource fits these scenarios so well. when you want one shared endpoint and key that can be used across several Azure AI offerings, such as vision, language, and document intelligence, you create an Azure AI Services resource because it acts as a unified gateway that fronts multiple cognitive services under one hostname and credential set. However, when your requirement is to access only Azure Document Intelligence and you want to secure that access using Microsoft Entra authentication, you provision an Azure Document Intelligence resource specifically, since it exposes its own endpoint and supports Entra-based tokens for that single service rather than a broad multi-service key. Question 58. For each knowledge store projection type, drag it to the correct description of what it represents. 1. Represents structured tables for relational analysis and reporting. Correct match. Tables. 2. Stores enriched data as JSON documents that can be exported or integrated into ETL workflows. Correct match. JSON objects. 3. Saves extracted visual assets such as embedded document images. Correct match. Image files. Now let's quickly walk through why these matches are correct. Tables correspond to normalized relational structures, so they are ideal when you want to run analytics, reporting, or join the knowledge store output with other tabular data in tools like SQL or Power BI. JSON objects, on the other hand, keep each enriched document as a full JSON record, which is perfect for exporting into pipelines, data orchestration tools, or NoSQL stores where flexible schema and nested fields are needed. Finally, image files are used when the indexer pulls out visual content, such as embedded images from documents, and saves those as separate assets, allowing you to reuse or process the extracted pictures independently of the text. Binary blobs and vector embeddings are not projection types used here, so they remain unmatched in this question. Question 59. Arrange the following steps involved in creating an analyzer through the REST API in the correct order. 1. Prepare the JSON schema definition for the analyzer. 2. Send a put request with the JSON and API key in the header. 3. Receive operation location from the response headers. 4. Poll the operation location URL until status shows succeeded. Now let's go through why this is the right sequence. First, you must prepare the JSON schema definition for the analyzer because the REST API needs to know exactly what configuration you want to create before you send any request. This JSON describes the analyzer's name, parameters, and any resources it needs, so it is always the starting point. Next, you send a put request with the JSON and the API key in the header. The put verb is used to create or update the analyzer resource, and the API key authorizes that call against the service endpoint. Without this step, the service never receives your configuration. After the request is accepted, the service responds with headers that include an operation location value. This URL represents a long-running operation handle for the analyzer creation. So the third step is to capture that operation location from the response headers. Finally, because analyzer creation is asynchronous, you do not get an immediate success result. Instead, you repeatedly poll the operation location URL until the status field in the response changes to succeeded. At that point, you know that the analyzer has been fully created and is ready to use in subsequent operations. Which are possible status values returned in the JSON response for an analysis operation? Select 3 answers. Option A, pending review. Option B, running. Option C, completed manually. Option D, succeeded. Option E, failed. The correct answers are running, succeeded, and failed. Now let's walk through why these 3 are right and the others are not. First, running means the service has accepted your request and the analysis is still in progress. When you poll the operation status endpoint, seeing running tells you to keep checking until the work is finished. Next, succeeded indicates the analysis has completed successfully. At this point, you can safely read the result payload because the operation has finished without errors and the output is ready. Finally, failed tells you the operation did not complete successfully. In this state, you typically inspect error details in the response to understand what went wrong, such as invalid input, permission issues, or service errors. On the other hand, pending review and completed manually are not valid status values returned by this API for analysis operations. They might sound plausible, but they are not part of the defined status set. So if you see them in options, you should rule them out.